Good morning, everyone. Today we are going to discuss the topic of hand instruments. In this, the contents would include introduction, history, materials, classification, exploring instruments, parts of hand instruments, instrument nomenclature and formulae, instrument design, cutting instruments, restoring instruments, finishing and polishing instruments, instrument sequence, instruments techniques, rest, sharpening of instruments, conclusion, and references. First, introduction. The term instrument refers to a tool or a device to implement used for a specific purpose or type of work and is preferred in professional or scientific fields as precision items to perform specific procedures. Instruments are used to examine, clean, cut, and restore the tooth. The main types are either handheld or rotary instruments driven in a handpiece. In order to perform the detailed procedures associated with operative dentistry, the dentist must know what are the instruments available, what is the purpose of each and every instrument, the position and manner, how to use, and its applications. Now, first coming to the history. Early hand-operated instruments were almost of this shape. They used to be large, heavy handles, and inferior metal alloys. Cumbersome, awkward to use, ineffective, no uniformity in the uniformity of manufacture or nomenclature. Usually, they doesn't have any sort of specified features for their manufacturing. Later, Dr. G.V. Black was the first person who was being credited with this first acceptable nomenclature and classification of hand instruments. Dr. Arthur D. Black developed many of the instruments and techniques. Next, coming to Dr. Charles E. Woodbury, first to modify Black's instrumentation, designed 39 sets of hand instruments for class 3 cavity preparation and condensing points for building gold foil restorations. As in the previous days, gold foil was one of the most commonly used restorative material. So he invented instruments for gold restorations. Next, coming to Dr. Wedelstedt, he developed chisel, now referred to as curved chisel. Next, Dr. Walden Ferrier, he developed a new set of instruments called Ferrier set, which were more refined and had uniform thickness on the cutting edge. Next, Dr. George Hollenbeck, he invented pneumatic condensers. They are also most commonly used for the direct filling gold restorations. Now coming to the materials. Most of the hand instruments are of two types. They might be either carbon steel or stainless steel. Carbon steel, the composition would be iron, which is 98.4 to 98.6, carbon 1 to 1.2, manganese 0.2, silicon 0.2. Other than this carbon steel, stainless steel can also be used. Stainless steel, the composition would be iron 81 to 81.4 percentage, chromium 18%, carbon 1%. When compared to the carbon steel, they are more harder than stainless steel, but when unprotected, it corrodes. Coming to stainless steel, that reduces the corrosion tendency. It also helps for maintaining the sharpness of the blade. Maintaining the sharpness of the blade would be a problem for this. They are very better in carbon steel when compared to the stainless steel. It loses a keen edge during much use. So stainless steel, the tip of the stainless steel instruments will usually get more eroded easily when compared to the carbon steel. Next, coming to heat treatment. Hardening treatment and tempering treatment. The steel is heated to 1500 degrees centigrade to 1600 degrees Fahrenheit and then quenched in oil to harden the working edge. Quenching means suddenly these instruments, after heating, they will be kept in the water. Here, they are being kept in the oil. Not more than 1 to 2 mm of the tip is heated for hardening purpose. Otherwise, the instrument will lose its balance after sharpening. Hardness hardens the alloy, but it also makes it brittle, especially when the carbon content is high. Next, coming to the tempering treatment. In this, the cutting edges are usually tempered to produce additional hardness and to remove some of the brittle properties. Tempered means they will be very much heated, and later they will be beaten with the hard instruments. To accomplish this, the tip is reheated at a lower temperature. They are quenched in solutions of oil, acid, or mercury at 200 to 450 degrees centigrade for 10 minutes. So as I've already told, this quenching means they will be suddenly, they will be after high heating, they will be tempered with a hard instrument, and after that they will be kept in a oil, acid, or mercury. This treatment relieves strains and increases the toughness. Now coming to the classification of the instruments. According to the Marzu, there are actually various classification types for the hand cutting instruments. First one is Marzu's. In Marzu's, he classified instruments into 4 types: exploring instruments, removal of the tooth structure, restoration of the tooth, finishing, and polishing. First, the exploring instruments would include mouth mirror, explorers, periodontal probes, tweezers. Next, removal of the tooth structure, there will be hand cutting instruments or rotary cutting instruments. Hand cutting instruments are chisels, excavators, special form of chisels. The rotary cutting instruments would be handpieces, abrasives, and burrs. For restoration of the teeth, there will be the most commonly used instruments would include spatulas, plastic filling instruments, condensers, burnishers, carvers, files, knives. And for finishing and polishing, it would include finishing strips and burrs, brushes, rubber cups, cloth, felt, etc. Next, coming to Cherbynov's classification. These cutting instruments are classified as hand, such as hoes, chisels, hatchets, excavators; rotary, burrs, discs, stones; condensing instruments, pluggers, hand or mechanical; plastic instruments, there are spatulas, carvers, burnishers, packing instruments; finishing and polishing instruments. Coming to first hand, they would include orange wood sticks, polishing points, finishing strips. For rotary instruments, they will include finishing burrs, mounted brushes, mounted stones, rubber cups, impregnated discs, and wheels. For isolation instruments, they would include cotton roll, rubber dam, saliva ejector, excavating tips, miscellaneous, mouth mirrors, explorers, probes, scissors, and pliers. Next, coming to G.V. Black's classification. Till now, we read about the Marzuk's classification, Cherbynov's classification. Now we are reading about the G.V. Black's classification. It includes the cutting instruments, condensing instruments, plastic instruments, finishing and polishing instruments, isolation instruments, and miscellaneous. Next, students' classification. In students' classification, they are broadly divided into cutting instruments, non-cutting instruments. In cutting instruments, they would include excavators, chisels, and other. In excavators, again, they are subdivided into ordinary hatchets, hoes, angle formers, spoon excavators. In chisels, it would be straight, curved, bin angle, enamel hatchet, or GMT. The others would be knives, files, scalars, carvers. The non-cutting instruments would be amalgam condensers, mirrors, explorers, or probes, and other. Now coming to the next type of classification according to Pickett's, instruments used for the for examining the mouth and the teeth, such as mouth mirrors, probes, and scalars. Instruments used for removing caries and cutting teeth, such as excavators, chisels, hatchets, and hoe. Instruments used for placing and condensing the restorative material, such as plastic instruments, condensers, or pluggers, carving and finishing instruments. Among all the instruments, first coming to the exploring instruments, the mouth mirror. The head of the dental mouth mirror is usually round, and most commonly used sizes are number 4 and 5. And the interesting fact in the mouth mirror is its other name. The other name for the mouth mirror is odontoscope. Uses. The main uses of the mouth mirror is for retraction of the buccal and linguals of tissues. It easily enables either the direct vision or the indirect visualization. Illumination when used along with a light source. Better ergonomic position for the operator. With the help of the mouth mirror, the operator usually will have better ergonomic position. Now coming to types of mouth mirrors. Based on the material, they are classified as stainless steel or plastic. Based on the sizes, they are again divided into 5. Size 1, which is 16 mm, 2, that is 18 mm, 3, 20 mm, 4, 22 mm, and 5, 24 mm. Based on reflecting surfaces of the mirror, flat surface mirrors, they have reflective surfaces, silver coating on the back of the glasses. This gives the image a ghost image. Flat surface mirrors, they usually have a reflective surfaces such as silver coating on the back of the glass. Back of the glass. Next, coming to concave, they magnify the image but causes image distortion. Front surface mirrors, they have reflective coatings, that is rhodium on the top of the glass. It eliminates the ghost image. Front surface mirrors. The rear surface has a reflective surface beneath the glass so that the image is actually seen through the thickness of the glass twice. It can produce a double image, but the glass surface means that it is resistant to damage. For clarity of vision, the reflective surface of the mirror should be on the external surface of the glass. This type of mirror is called front surface mirror. However, they are easily scratched and so care should be taken, particularly during the cleaning and the sterilization. They can be scratched over the mirror surface. Next, coming to the advances of the mouth mirrors. Mouth mirrors with dual function are introduced recently. Example, mouth mirrors with illumination and the mouth mirrors with the suction. See, in the picture, we can clearly see that the mouth mirror handle is usually thicker in size. They are double-sided mirrors. In this is the first picture shows the mouth mirrors with illumination. We can see a clear light coming from the shank side. Next one is the mouth mirrors with the suction. The yellow tubes which are seen are used for suction. Next, third one is microsurgical mouth mirrors. The bigger one which is on the left side is the normal sized mouth mirror, and which is on the right side is a microsurgical mouth mirror. Explorers, for actual physical identification of the lesion, it might be either single-ended or double-ended. That means the exploring tip can present either only on the one end or it can even be present on two ends. So as we can see in the diagrams, the first one is shepherd hook explorer. This next one is straight explorer. The third one is pigtail or cow horn explorer. And the fourth one is odd one or 1718 explorer. Next, coming to uses of the explorers. These are usually used for the exploring lesions, for detecting and assessing carious lesions, for detecting demineralized dentin, for releasing debris from the tooth, for removing slight excess fill up around the cavo-surface margins. That is, if any restorative material is being excessively filled, then such things can be seen. Identifying hypersensitive areas in the tooth and assessing marginal fit of the restoration. While assessing the marginal fit also we can see. Next, interproximal explorer number 17, which is most commonly used in the back action. These are few explorers. The second one is the cow horn explorer. The third one is the shepherd explorer, and the sixth one is especially used for the endodontic procedures, which is DG16 explorers. Next, coming to combinations, there are various combinations, such as first one is the DG16 endodontic explorer. Next is DG16-17 endodontic explorer. Next is DG16-23 endodontic explorer, which have the shepherd hook tip on one side and DG16 tip on the other side. Next, coming to probes. They almost look like straight explorers, but they have blunt end, which is marked with gradations. Uses of probe mainly used for measuring the pocket depth to determine the dimensions of the tooth preparation. Types would include Williams probe, WHO probe, periodontal screening probe, or CP ITN. These probes differ in usually diameter and the position of the markings. In the picture, we can clearly see various types of markings, which is in the tip, there will be a ball shaped structure, which is about 0.5 mm in diameter. Next, the markings would be, first marking would be at 3.5, then a black band would be seen up to 5.5. After that, the next marking would be seen at 8.5, and then again one at the 15 mm, we can see clear markings. Next, coming to tweezers. Tweezer is a hand instrument with two narrow and pointed straight or curved beaks used to grasp the small objects. Consists of locking device. Usually there will be a locking device, two long arms joined at one end, and the other end remains apart. Users useful to place and remove cotton rolls, gauzes, and other small materials to and from the mouth. Next, coming to locking tweezer, may be a locking device to maintain the beaks in a closed position until released. This avoids the unnecessary anxiety of the operator at the possibility of slippage, whatever is carried by the tweezer. Now again coming to the parts of the hand instruments. The first one is the handle, that is the middle part over which we carry. The next one is the shank. Shank is the part which connects the handle to the cutting edge. Blade with cutting edge or nib with the face. The tip of the instrument is called cutting edge. So as we can see in the picture, it can be either single-ended or double-ended. Next, shaft. It is used as handle is straight, may be serrated to increase the friction for the hand gripping. Next, coming to the shank. It connects the shaft with blade or nib, usually tapers with its connection with shaft to where the blade begins. It is here where any angulation in the instrument can be placed. Parts. Next, coming to the blade, it is a part of instrument bearing cutting edge. It begins at the point which terminates shank. Next, coming to types of handles or shafts, they are available in various sizes and shapes. They can be hexagonal or octagonal, smooth, serrated, or knurled. Serrated for better gripping and control of the hand instruments. Length 5.5 inches. Standard stainless steel handle is usually of the diameter 6.4 millimeters. The larger diameter handles also are available, such as up to 9.5 mm. They occupy more space in the instrumentary. Instruments used primarily for the tactile and exploring purposes, for example, probes, have smaller diameter, lightweight handles, instruments designed to transmit heavier pressure and which will be held for the long periods of time. For example, scalars have larger diameter, heavier handles. Next, handles are in conjunction with the shank, or it may be separable. Separate type is known as cone socket handle and allows for the replacement of the several working ends. Example, mirrors and the condensers. Blade. Functional end of the instrument is connected to the handle by the shank. The tip is the cutting edge, and that part is known as blade, which connects the cutting edge to the shank. Some instruments have a blade on both ends of the handle and are known as double-ended instruments. The blade ends in cutting edge and are mostly beveled. The cutting edge is the working part of the instrument. The blade angle is the angle between long axis of the blade and the long axis of the shaft. The cutting edge angle is angle between the margins of the cutting edge and the long axis of the tooth. Between the long axis of the tooth and between the cutting edge and the long axis of the shaft of the instrument. Next, coming to bevel. Beveling of the blades, it might be either single beveled or bi-beveled or triple beveled or circumferentially beveled. Beveling is something like a blunting of the cutting edge on one side. That is known as beveling. It can be either single beveled or bi-beveled, triple beveled or circumferential beveled. Shank. It connects the handle to the blade. It is smooth, round, tapered. Instrument with long blades may require 2 or 3 angles in the shank to bring the cutting edge near to the long axis of the handle. Such shanks are termed as contra-angle shanks. Next, coming to the according to GV Black, if the instrument contains one angle in its shank, it is called mono angle. If there are 2 angles, then they are called as bin angle. 3 angles, triple angle. 4 angles, quaternary angle. This nomenclature part we'll discuss in the next class. As of now, we have discussed completely about the classification, exploring instruments, and also the parts of the hand instruments. Okay.